What's up, everybody? It's me, Mr. Escobedo. I just wanted to quickly just go run through what our lab is going to be all about, okay? So our topic for today is Newton's Cradle, and this lab will be due by the end of the week. Hopefully the submission folder will be open for you guys by Thursday, Friday. So let's get started, all right? So the do now. Hopefully I was able to show you guys a cool do now video of me showing you guys Newton's third law in the bubble. If not, all right, let's see what we got. So we always got to review our objective, right? Right before we enter our lab. And just so you guys know, the lab is supposed to look like this, right? It should be in your folder. Some of you guys were able to get this copy yesterday with me. But if not, you may download it or upload it. But anyways, our objectives for today. Students will be able to relate Newton's third law of motion to everyday real life situation using Newton's cradle as a reference. If you don't know what Newton's cradle is, it actually is like this right here. All right, and I know some of you guys were able to see this and actually use this in the classroom. So as I'm speaking, I hope you guys have your labs right there with you or printed out, but I'm just going to review each part, right? So the question we are asked today for our lab is, how is Newton's cradle used to demonstrate the third law of motion? So our first law, we talked about inertia. Our second law, we talked about force equals mass times acceleration. And our third law, right, I broke it down into two parts. The answer which we always asked is action and reaction. But this time, I want to see you guys take it there using this lab, all right? So before we dive into our dive into our lab, we have to go through our hypothesis. So if I were you guys, I'd take the time right now to try to figure this out. So I would say, and this is how I started off, if I move one or more of the weighted balls on Newton's cradle upward and then release it, then blank. Try your best educated answer that you guys can fill in, and then according to Newton's third law of motion. So I'd let you guys take that. Here, I'll give you a few seconds for that. All right. Next, our research, right? And I'm following along our guideline for our lab, right? So the research, what we're seeing is, what is Newton's third law? Okay? And we got started yesterday and we actually developed it through our Nearpod. But in case you need a reminder, here's Mr. Escobedo explaining it to you. Newton's third law of motion states, for every action, there is an equal and opposite reaction. Okay? So let's keep that in mind while we're filling in this hypothesis and following to collect our data. Before we actually set up for me to use our Newton's cradle, I have to go over procedures, right? So our procedures for this, because I know some of you guys, we started this and we experimented this, and some of you guys got it, but some of you guys didn't. So here's the deal. Number one, observe Newton's cradle. So there are 5 balls in a row suspended from a frame, right? And these balls, they're all weighted, attached to the string. So this one says, there are 5 balls in a row suspended from a frame. Pull a ball away from one end of the row and then release it so it collides with the other 4 stationary balls. So this one would be the first one with the box empty. And all you're going to do is observe what's happening here, okay? Here we go. 1 ball. I'm going to try it one more time, all right? So your goal is to actually write or draw on the bottom of your lab what you just witnessed, okay? And when you're done with that, flip it over. And what I need you to do is follow along with the next side of the procedures. Number 4, it says, right? And it should be on the second page for you guys. It says, try this again, but this time pull 2 balls away from one end and release them and observe your results. See what you got. Write or draw your results on the box, all right? So now I'm going to do 2 balls. Holding it up. Hope you guys can see this. Ooh. Uh-oh. That was a fail. Hold on. I'll try that one more time. All right. Take the time to actually write this down or draw it. All right. Ooh, cool. All right. Finally, this time we're going to do 3 balls. Same situation. And all you got to do is observe, write, and draw your results. Ready? 3. Oh, boy. Here we go. One more time. Oh, one more time. Oh, man. That one's a fail. Let me see if I can get you guys at a better angle here. All right, here we go. All right. Hopefully that helped. All right, and our conclusion, right? After this, you guys would look back to your hypothesis, and you're going to ask yourself here, was your hypothesis correct or incorrect, right? And the way I want you to answer the second part of the question, which says, explain and make sure to include evidence of Newton's third law. If I were you guys, I would rewrite what Newton's third law is and how it connects to Newton's cradle, okay? Now, I did add additional base questions here for our data, and I'm going to quickly read this with you guys. Would the same results be seen if the balls were not the same size and weight? All right? This one's a thinker. I really want you to dive into this. And the next question, how does Newton's cradle demonstrate Newton's third law of motion? All right? Really take the time, write full sentences, guys. I know you got this, okay? I really want you guys to really fill this out. And if you still need help, please rewatch the video, see the examples. If not, message me. I am more than happy to help you guys. All right? Before I end this video, a few questions I always need you guys to reflect on. What is Newton's third law of motion? Can you state it? Can you define it, right? Because this is going to be for our one-pager that you guys also have to fill out. And if you need help, think about your activities every day, right? Think about me on a skateboard, or, you know, anything that you guys did that in terms of how does this apply to us, right? And make sure you can list that for yourself, right? If not, hopefully this video helped. Guys, good luck with everything. You guys are the best, all right? Take it easy.